Okay, so we've already talked about how sets are essentially a bag of stuff, right? So, for example, if I have the set A, B, C, D, and maybe we'll add the empty set to that, and the set containing the empty set. So there's my set. If I take that set, we can represent that as a bag of stuff. So that's a big bag of stuff, and in that bag we have an A. So we'll stick an A in there, and we have a B and a C, so let's put them in. And we have, what else? We have this D in a bag, right? So we need to make a new bag that has a D in it. And we have the empty set, so that's a bag with nothing in it. And then we have the set containing the empty set, that's a bag with an empty bag in it. So let's do this first one, which is just an empty bag. And the second one, which is this set that has the empty set in it, is a bag, and in that bag we're going to put the empty set, which is just an empty bag.
Right.
Okay, so we're going to take this and shrink that and put that up there. So what we're going to talk about right now is this concept of element versus subset. Let's start with subset. So if I want to know if I have a given set, whether it's a subset of another set, for example, let's suppose I have the set A, B, okay? And I want to know whether this set, whether AB is actually a subset of this one. So let's, just to make our lives a little bit easier, we'll call this set set 2, since it's the second one we made, and we will call this other one set 1. So the question that we have, or that we want to answer, is set 2 a subset of set 1? All right, so that's what I want to know. And so to figure that out, what we have to do is we have to say, is every single thing that's in set 2 also inside of set 1? So before we do that, let's just draw what's in set 2. Maybe we'll do set 2 in blue just to make it a little bit different. So set 2 is another bag, and inside of that bag there is an A and a B. So we're just going to put those into set 2. Okay? Alright, so there's set 2. So all we need to do, if we want to figure out whether set 2 is a subset of set 1, we just need to go through every element of set 2 and see if it's in set 1 somewhere. So if I look in set 2, I have an A here, which corresponds to that A there. And we can see, sure enough, that set 1 has an A in it. And we can also see it in there, right? It's just a plain old A. So we can kind of go check. A is in there. Well, what about B? Is B in there? Well, yep, it's there. And we can also see, here's my B in my set 2, and it's just floating around in my set 1. So we can put a check mark, and we can say that, yes, indeed, set 2 is definitely a subset of set 1. Okay, so I've cleaned it up a bit, and we can see that set 2 is a subset of set 1. We've said that. Oh, let me move these guys just up here a little bit. All right. So let me make a set 3, which is going to be very similar to set 2, but not quite the same. So set 3 is going to have an A in it. It's going to have a B in it. And it's also going to have a D in it. So there's my set 3. And if we draw set 3 is just another bag that has A, B, and D floating around in there. Okay. So let's shrink that a little bit, and let's put that there. So if I want to ask the question, is set 3 a subset of set 1? Well, again, I would look at all the elements of set 1 and set 3. So I would say, look, A, well, there's A in set 3, and sure enough, it's in set 1. And B is in set 3, and B is in set 1. And what about D? Well, D is in set 3, and I can see it right here, right? It's just floating around in there. But when I look at the things in set 1, and I have to kind of look at the top level and say, what's in this outer bag? And the answer is that in this outer bag, I have an A, I have a B, I have a C, and then I have just a bunch of bags. So this is a bag, it's got stuff in it, but it's a bag. Here's another bag, it has stuff in it. Here's another bag, it has stuff in it. So if I want to say, is D in set 1? Well, no, it's not. There's a bag with a D in it in set 1, but D itself is not floating around in set 1. So the answer is that S3 is not a subset of set 1. Let me grab that and shrink it down. Ooh, that's good, huh? Okay, so the last thing that I want to do is let's do another set. And we'll call this one set 4. And set 4 is just going to equal the empty set. And remember, the empty set is the same as a couple of curly braces with nothing in it, right? And we can also draw the empty set, right? If we draw it and represent it as a bag, it's a bag that has nothing in it, right? So there's our empty set. And here's my question, which is S4, or is the empty set a subset of, well, let's see, is the empty set a subset of S1? And the empty set is a subset of S1 if everything that's in the empty set is also in S1. So if we look in here, there's nothing in there. So kind of by default, everything that's in here is certainly in there because there's nothing in here. Similarly, we've got this empty bag, nothing in there. So yeah, it's in there. So what we have is the empty set is indeed a subset of S1. And in fact, it's not just a subset of S1, but the empty set is a subset of any set, right? It's even a subset of itself. Anything's a subset of itself. But the empty set is a subset of any set because no matter what set you check with, here you've got nothing to see if it exists in another set. So just to clarify, if I just shrink that for a minute, the reason that the empty set is a subset of this S1 has nothing to do with the fact that there's some empty sets in there. All it has to do is it says, look in this bag. What is in this bag? Everything that's in this bag, check if it's in this one. Well, there's nothing in there, so I don't have to check anything, so it is a subset. So we could also say, you know, is the empty set a subset of S2? And the answer is, of course, yes, because if I say, what's in the empty set? Nothing. So check every single thing in here. Okay, I'm done, right? Every single thing in here, is it part of here? Well, sure, because there's nothing in there. So no matter what is in S2, I know that the empty set is indeed a subset of S2, and in fact, the empty set is a subset of everything. So now let's talk about this question of whether something is an element of a set, right? So we can ask the question, for example, is A an element of set 1? And the answer is that A is an element of set 1 if you can find an A inside of this outer bag that represents set 1. So if I look around here, there's an A, so the answer is that yes, indeed, A is an element of set 1. Okay, so let's do another example. Let's try and find out whether the set containing A is an element of set 1. And now let's draw our pictures again, because what we're trying to see is this whole thing, can we find that inside of this set? And this whole thing, if we draw it as a picture, what we end up with is a bag with an A in it, right? And so what I want to know is, do you see in this big bag a bag with an A in it? And the answer is I don't. I see an A by itself. I see a bag with another empty bag in it. I see a bag with nothing in it. I see a bag with a D in it and a B and a C. But nowhere inside of the outer bag do I see a bag with an A in it. So that means that A is not an element of S1. Okay? Let's try another example. Is the empty set an element of S1? Well, the empty set is an element of S1 if, when we look inside this bag, we see the empty set. In other words, if we see a bag with nothing in it. And in fact, we do, right? Because if we look inside this bag, there's a bag with nothing in it. So the empty set is indeed an element of S1. Now, the empty set is not an element of every set, right? Because if we think about for a second, you know, the set AB, well, the set AB is a bag that has an A and a B floating around in it. So now the question I have is, if we call this maybe, I don't know what number we're up to, so we'll call it S5, is the empty set an element of S5? So let's take this guy and shrink it. We already said the empty set is indeed an element of S1, but our question now is the empty set an element of S5? Right? That's our question. And the empty set is an element of S5 if we can find this bag somewhere inside of this one. And when I look, I don't see an empty bag in there. I see an A and I see a B, but I don't see an empty bag. So it's not an element of S5. So even though the empty set is a subset of every single set, the empty set is not an element of S5. So how is it a subset but not an element? Well, remember that when we talk about the concept of subset, when we're talking about subset, for example, if we are asking, is S5 a subset of S1, then we're asking, if I look inside of S5's bag and look at every single thing in the bag, do I also find that in S1's bag? When I'm talking about element, then I'm saying, is this thing, which is not necessarily a bag, found in my bag? So if I want to say, is D an element of S5, right? Then what I'm saying is, when I look in the S5 bag, do I see a D, right? And that's very different from saying, is everything in one set in another? So subset, you absolutely have to have two sets. I can never ever ask, is D a subset of S5? Because D isn't a set. And in order to have a subset, you have to have a set. But I can say, is D an element of S5? Now, if I want to look for elements, I can always take a set and find out if that's an element of another set, because, for example, in here, I have the set containing D is an element of S1, because when I look inside S1, the set containing D is in there. So let me just try and clarify one more time. Let's suppose that I have a very simple set. So let's consider, let's suppose I have the set, still have no clue what we're up to, S7, and S7 is the set A, comma B, comma C. It is the case that the set containing just A, which we'll call S8. Now, it is the case that S8 is a subset of S7, because if we go through everything that happens to be in S8, let's see, what's in S8? Oh, there's an A. Then I say, oh yeah, that's in S7 too. So for subset, both sides of the subset equation have to be sets, because what you're saying is everything in this first set can also be found in this second set. So I have an A in there, I have an A in there, so I say, yep, it's a subset. So let's shrink this stuff and put it up there. So let's make an S9, and let's let S9 be the set containing A, B. And here's my question, is S9 a subset of S7? Well, the first question you have to ask yourself is, are they both sets? And yep, S9 is a set, S7 is a set, so far so good. And then we say go through everything in S9 and see if it's in S7. So A is in S9, A is in S7. B is in S9, B is in S7. I'm done, so I say, yep, S9 is a subset of S7. Let's try one more. Is S9 a subset of S8? Well, let's see. The first thing we need to do is we need to make sure they're both sets, because you can only do subset if they're both sets. So S9 is a set, S8 is a set, so we're good. And then you have to go through set 9 and say, is everything that's in set 9 also in set 8? So we look and we say, A is in set 9, A is in set 8. So far, so good. B is in set 9. Uh-oh, B's not in set 8. That means that S9 is not a subset of S8. In fact, S8 is a subset of S9, right? Because everything in S8 exists in S9, but not the other way around. Furthermore, if they were both subsets of each other, then they'd be the same set. Okay, so that's all about subset. And remember, one of the most important things about subset is you can only have a subset if the thing on the left of the subset symbol is a set and the thing on the right of the symbol is a set. So we've talked about subset. Now let's talk about element. When you're talking about element, usually, traditionally, when you were doing this in high school, the thing on the left was not a set. So when you're trying to figure out something like, why don't we underline element in blue, and I'll do my element stuff in blue. So if you want to know, is A an element of S7? Notice that the thing on the left, A, is not a set, but S7, if we look at it, has these set brackets. So S7 is a set. When you have element, the thing on the right has to be a set. The thing on the left can be a set, but doesn't have to be. So if I want to say, is A an element of S7, I say, let me see if I can find this thing in S7. So I look in S7, and I see an A floating around in the bag. So I say, yes, indeed, A is an element of S7. Okay, let's try something else. Is the set containing A an element of S7, okay? And the set containing A is an element of S7. This is an element of this. If the thing on the right is a set, well, it is. And if this thing appears inside of this thing, so this is an A in a bag. And I say, is there an A in the bag inside of S7? No, there is not. So the set containing A is not an element of S7. Having said that, we know that the set A is indeed a subset of S7, right? Because now we've got a set on the left, a set on the right, and everything that's in here is also in here. So let's just take a look at this set 1 again that we had from before, and let's talk about some other elements that are in here. So when I look, I see A in there, so A is an element of S1. B is in there, so B is an element of S1. I see a bag with nothing in it in there, so that means the empty set is an element of S1. But the empty set's not inside of S9, so we can say that the empty set is an element of S1, but the empty set is not an element of S9, because if we look in this one, there are no empty bags in S9, even though the empty set is a subset of S9, because the empty set is a subset of every set.